In this video, you are going to learn how merge sort works. First, we will be looking at the working of merge sort with an example. Then we jump into the code, and finally we will be looking at the advantages, the drawbacks and some applications of merge sort. So without any further ado, let's dive into it. In simple terms, we can say that the process of merge sort is to divide the array into two halves. Sort each half and then merge the sorted halves back together such that after merging we always get the sorted array. This process is repeated until the array is sorted. Let's apply this process to an example. As always, we have an array of 5 elements: 20, 4, 18, 0 and 7. Initially, merge sort divides the array into two equal halves. If the array consists of odd number of elements, the single element could be placed at any of the two halves. So our array would be divided into two subarrays. 20, 4 and 18 is the first half and 0 and 7 is the second half. These subarrays can further be divided. So 20 and 4 becomes a subarray, 18 becomes a subarray, 0 becomes a subarray and 7 becomes a subarray. Now some subarrays like 18, 0 and 7 have reached a unit length. That is, they contain a single element, and an array of single element could not be further divided and are always sorted. So these sorted subarrays or unit length subarrays are merged with another subarray such that the new array will be sorted. Continuing our example, we have a subarray of two elements. So we divide it. 20 and 4 becomes a unit length subarray. 18 could not be merged as it has no unit length subarray to merge. So it remains as it is. 0 and 7 gets merged. The subarray of 0 and 7 is sorted. Again, the process continues. 20 and 4 merge to form a new sorted array of 4 and 20. 18 remains as it is, as it do not have any array to merge with. The subarray 4 and 20 merges with 18 to form a new sorted array of 4, 18 and 20. Finally, the remaining two subarrays merge with each other to form a sorted array of 0, 4, 7, 18 and 20. Yes, we figured out how merge sort works. I highly recommend you to solve an array of 10 elements of your own using this idea on paper before you move to the next section. To understand the code for merge sort, you have to be clear about the working. I hope you have solved an array on paper. So let's look at the code. We have a basic structure of a C file. We have included the headers. We implemented a print array function which just prints the array. In the main function, we have implemented or declared an array to work with. Then we have a variable n which contains the size of the array. We print the array before it is sorted. We call a merge sort which to sort the array. After sorting, we print the sorted array. Then we implement the merge sort function which takes arguments array, leftmost element of the array L, the rightmost element of the array R. It checks if L is less than R, meaning if the array has more than one element, we create a new variable called mid, which is the middle element of the array. Then we recursively call merge sort for the leftmost elements of the array and recursively call the merge sort for the rightmost element of the array. Then we merged all the left, mid and right so that we get a sorted array. Let's look at the function of merge. The merge takes arguments array, the leftmost element, the mid of the array and right of the array. We implement variables I, j, k which are the counters. I is the counter for left array, j is the counter for right array and k is the counter for original array. N1 represents the index of the elements to the left of mid, including the mid, basically the size of the leftmost elements. N2 is the size of the rightmost elements. We create two temporary variable L and R. L stores the leftmost elements of the original array and R stores the rightmost element of the original array. We create a for loop which just stores the left elements from the mid of the array to the array L, and another for loop which stores the right elements from the mid of the array to the array R. We update all the counters to their initial value. I becomes 0, j becomes 0 and k to the leftmost element of the original array. Remember, I represents the counter for the left array, j represents the counter for the right array, and k represents the counter for the original array. In the while loop, it checks if I is less than n1, that is, the counter for the left is less than the size of the left array, and it checks if the counter for j is less than the size of the right array. If so, it checks if the current element of the left array is less than the current element at the right array. If so, the element is placed at its correct position in the original array and I is incremented. Else, if the right element is greater than the left element, the right element is placed at the position. After the while loop, we copy all the remaining elements in the left array to the original array. Another while loop, copy all the remaining elements in the right array to the original array. Let's see the output, and we can see the array before sorting 20, 4, 18 and 0. After we run the merge sort, we can see the array is sorted 0, 4, 7, 18 and 20. Instead of using temporary arrays to store left and right elements, you can also use queues. If you are familiar with queues, then try it out. By the way, the source code is in the description. The time complexity of merge sort is big O of n log n in all three cases, as merge sort always divides the array into two halves and takes linear time to merge two halves. The advantages of merge sort is that it is a stable algorithm, that is, it maintains the relative order of equal elements in the input array. Merge sort has a worst case complexity of big O of n log n, which makes it to perform well even on large datasets. Merge sort is naturally a parallelizable algorithm, that is, merge sort takes advantage of multiple processors or threads. The downside of merge sort is that it requires additional memory to store the merged subarrays during the sorting process. Merge sort is not applicable in places where memory is a concern. For small datasets, merge sort has a higher time complexity than some other sorting algorithms like insertion sort. This results in slower performance for very small datasets. So, the applications of merge sort is well suited for sorting large datasets due to its guaranteed worst case complexity of big O of n log n. Merge sort is commonly used in external sorting, where the data to be sorted is too large to fit into the memory. Merge sort can be adapted to handle different input distribution, such as partially sorted, nearly sorted, or completely unsorted data. Finally, if you have found any value in this video, then hit that like button. If you want to see more videos like this, hit that subscribe button. Congratulations on mastering merge sort. Signing out.